Have you ever wondered how DC generator works and what are the basic parts of DC generator? This video gives you the answers to these questions. We will start with basic parts of elementary DC generator. As you can see, the configuration of DC generator is pretty simple. The starter is fixed part of the DC generator. The starter consists of permanent magnets, two of them which is placed to fit around the rotor. The main function of starter is to provide the magnetic fields through which rotor or armature coil is rotated. Armature loop are generally placed in slots of armature core. The armature coil is formed by connecting several loops in the series. Armature winding is formed by connecting several coils in the series. The armature loop cuts the magnetic field due to which an electromotive force is induced in it. The split ring is a movable device used for reversing the polarity of the current. It is made of copper. The ring is divided through the middle into two parts. We must use a split ring to achieve single direction of current. The brushes are made of carbon. These are rectangular block shaped. The only function of these carbon brushes of DC generator is to collect current from the commutator segments. A galvanometer is an analog electromechanical actuator that produces a rotary deflection of some type of pointer in response to electric current. So how does the DC generator work? Firstly, we don't want the current direction to change. We want it to remain the same at all times. Let's say in this direction. So how do we do that? To make sure that the current direction remains the same, what we require is that these brushes constantly keep changing contacts between these wires for each half of rotation. So, if the current flows in this way, in this position, this brush must be connected
But when the coil rotates, you can see that when the coil comes to this position, the direction of the current changes. If we want to keep the current in same direction, we must use brush to be in contact with this wire. Right, and then again when the coil comes to this position, again the direction of the current changes. And then again we want this brush to come in contact with this wire. Probably we already learned that for every half rotation, we must change contacts between brushes and wires. But how do we make this process automatically? We can alter this process by adding split rings. Split rings, as the name suggests, is a ring that is split in between. There will be two half rings with same gap in between. Now let's see how the split ring automatically change for every half rotation. So right now this brush is in contact with this half part of the split ring, violet color. When the coil rotates and comes to this position and the direction of the current changes, and this brush now in contact with other half part of the split ring, pink color. This arrangement provides that the current flows in same direction again as coil comes to this position, finishing another half rotation. You can see that this is only changed contacts. Brush is in contact again with violet color half part of the split ring. In this way, the DC generators built when the current only flows in one direction, any external circuits, and then this arrangement with brushes and split rings which helps us to automatically change contacts, we call them commutators. So split ring act like commutators.
Next, we must mention that is very important for working principle of DC generator is how we can determine the direction of current, magnetic field and force. To determine all this, we must use Fleming's right hand rule. So, we will explain how we can use Fleming's right hand rule. As you can see, the rotation of the coil is clockwise and force acting on the part of the coil AB push the part of the coil backwards. To know the direction of induced current, we apply Fleming's right hand rule. How do we do that? We place our right hand so that thumb points up showing the direction of the force. The index finger points to the direction of magnetic field from north to south, and middle finger will point the direction of induced current, which is now case from A to B. Similarly, to find induced current in the part of coil CD, we again use Fleming's right hand rule. So the rotation of the coil is clockwise and force acting on the part of the coil CD pushing the part of the coil downwards. The thumb indicates the direction of the force. Index finger indicates the direction of magnetic field from north to south, and the middle finger indicates the direction of induced current. So to conclude the induced current, follow the path from ABCD of the coil.
The effect of the split ring, commutator and DC generators is to ensure that the induced EMF is always in one direction. We can see that in this graph where V represents the amount of induced EMF and T represents time. You will notice in the graph how the sine wave changes with rotational speed of the coil. The coil in this case has clockwise rotation. Increased rotational speed of the coil increases the amount of induced EMF. The induced EMF has a positive sign. Also you see the example how the sine wave changes with rotational speed of the coil when the coil is rotating counterclockwise. Again, the increased rotational speed of the coil increases the amount of induced EMF. In this case, the induced EMF has a negative sign. To conclude, the DC generator has many advantages, like the design is simple to operate, highly reliable, constant voltage can be achieved, speed control is easy. Also, DC generators are added in many applications like boosters and welding equipment to charge batteries and solar systems, and in emergency at your house and offices.